Welcome back. We're going to have a really short video here, just reviewing the scientific method. And then in the next video, we'll talk about Chapter 2. Chapter 1 in this book is very, very short. So, scientific method, you have probably heard about before. You might have even been taught the scientific method as far back as the early grades of elementary school. But just to give you a refresher, the scientific method is nothing more than a series of thoughts and actions that a scientist will go through when investigating the world. And the process always starts with an observation, which sparks an idea, or what we call a hypothesis. This hypothesis is then tested to see if it is correct. And we can see a flowchart here. This is one of the better ones that I've found. It doesn't actually match what's in your book. The one that's in your book is slightly different, but I do like this one better. The scientific method, as we'll discuss in just a second, it's not what most people think in terms of there just being you do this, and then you do this, and then you do this. Like, it's not a step-by-step process that is very clean. The scientific method is actually kind of messy sometimes. But before we get into that, the overall structure of using the scientific method is you see something, you have some kind of an observation that then sparks an idea that is an attempt to explain what you observed. So this is what we call a hypothesis. So the hypothesis tries to explain the observation. You then will design an experiment to try to prove or disprove your hypothesis. And if you're being a good scientist, you actually don't care which, whether you want it to be proven or disproved. You just want to get the best data possible. Now, obviously, we are not robots, and depending on what you're actually studying, you will want either want your hypothesis to be correct or not want it to be correct. So that's something we always have to fight back against, as our humans tend to have bias in these kinds of situations, and so we tend to read data with that bias in mind. So we have to constantly fight back against that. But when we create this experiment and we get the results or the conclusion from that experiment could either support our evidence or it could be inconsistent. It could support our hypothesis or it could be inconsistent with our hypothesis. Either way, we're going to do more experimenting. So you notice here, both of these arms, so to speak, on the flowchart lead back to the experiment. It's just over here, if it was inconsistent, maybe we make some changes. Maybe we revise our hypothesis slightly. We think about it in a different way. We try to come up with a different idea that explains what we saw. If we have evidence that supports our hypothesis, we are still going to do more experimenting, and we would still even try to make up new experiments, but we would at the very least reproduce the experiment to show that we get the same results more than once. If you can only get a result once, that means that your first result was not actually correct. There are no situations where you would be able to get one result and then every other time you do the exact same thing you get a different result. That should not be scientifically possible anyway. There might be situations where the experiment is just so difficult, there's so many random uncontrollable variables that it's difficult to reproduce. But even then, that doesn't mean that you get to just say, well, I like my first result better, therefore it's correct. No, that's not how science works. If there's so many things wrong with your experiment that you can never get the same result twice, then you need to rethink your experiment. So again, either way, we're going to do more experimenting here, and we're just going to do more experiments, revise, more experiments, more revisions, and this is the one part of this flowchart that I don't like very much. We're not going to go, once we do this enough, we don't go straight to a theory. At the most, it might go straight to a law, maybe. But a theory is a much more foundational thought than a law is. But regardless of that, even after that point, where we've done so much experimentation, we've done so many experiments, and the experiments have been done by many, many people over decades of time, that everyone agrees that we have a scientific theory, we're still doing more experimentation. Science never ends. We never say, all right, done. Science is finished, everyone. Like, that's never going to happen. We're still going to do further experimentation, because there are plenty of things that people thought back even less than 100 years ago that people thought were absolutely true, and now we know they are 100% not true. There's plenty of things like that. Let's see here, yeah. Real quick before we finish up this video, I mentioned how the scientific method is not just this really nice step-by-step process, that it can get a little bit messy. The reason for this is that oftentimes in these two steps here, where we form an experiment and then get a conclusion from that experiment, oftentimes what happens is either the conclusion is not quite consistent or inconsistent. It's kind of in between, where we're not even really sure what the result is telling us. Or maybe, and this happens quite often as well, we'll get a result, and instead of the result giving us an answer for the experiment that we're looking at, we might get a result that then brings up a whole new hypothesis. We might have essentially a whole nother one of these branches sprout, where we're like, oh, we weren't expecting that result. Maybe this other thing is going on. And so the scientific method isn't really so much just a start with this step and then go to the next step and then go to the next step. It's more like a tree where you start at one point and you get multiple questions that result, and then you start to look at those and you get even more questions as you go from there, and just it grows and just gives you more and more things to think about. So scientific method, very, very useful way to think about things, but not quite as straightforward as some people try to make it out to be sometimes. But nonetheless, it is still an excellent way to try and think about the world. All right, we will call it there. In the next one, we'll jump into Chapter 2. So I'll see you